Hi everyone, my name is Bijisa Pyakurel, and today I will be talking about my work, Cogcues, shifting perception through interactive projected cues in still life drawing. I will be presenting on behalf of my co-authors, Shreyosi Endow, Donjuan, and Cesar Torres. This work was developed at the Hybrid Atelier in the Department of Computer Science and Engineering at the University of Texas at Arlington. Drawing from life is difficult because we are made to translate our 3D understanding of the world onto a 2D canvas. Drawing instructors emphasize the concept of the innocent eye to see an object in its unfamiliar and unbiased form. Psychology links this way of seeing to accessing an enhanced proximal mode, or P mode of perception. This mode allows artists to attend to the raw visual stimuli that meet the eye. To accurately depict an object, a skilled artist must strategically leverage and suppress their subjective world associated with the distal mode, or D mode of perception. For instance, while our D mode perception may make this coffee cup appear white, our P mode of perception would bring our attention to the shadow on the rim of the cup, which produces a gray stimulus. The innocent eye, and by extension P mode perception, allows artists the ability to flexibly deploy their attention and to guide visual selection. Difficulty in shifting between the two modes leads to misperceiving reference objects and scenes, which is a major source of drawing errors. Techniques for recovering the innocence of the eye and modern drawing training tools are primarily motor input or skill-based. We focus on the underlying perceptual mechanisms that contribute to these motor errors. Our work takes the first step towards understanding how light projection-based spatial augmented reality, or LPSAR systems, can be used in drawing as a cognitive training tool to train the eye by manipulating visual stimuli to enhance and suppress P mode and D mode perception. We designed a reconfigurable SAR system for projecting visual cues onto still life drawing objects within the drawing studio. A depth camera extracts the drawing object from the scene, and a light projector is used to project the dynamic light cue onto the drawing object. Each cue is interactive and controlled by the user using a MIDI control board. We present 3 scene dynamic reconfigurable light cues, which we term Cogcues. Each Cogcue is motivated from established drawing techniques in psychology literature to counteract misperceptions in drawing and address perceptual challenges faced by novice drawers. The grid Cogcue is inspired by the grid drawing technique. It maps a grid onto the mannequin to guide positioning and to avoid D mode biases associated with the human form. Users are given control over grid density, stroke width, illumination, and row selection using the MIDI controller. The invert Cogcue uses the figure ground principle and opponent processes theory of color perception to amplify the contrast between the figure and the ground of the mannequin image. This allows users to more easily process global aspects of the image using visual selection enabled by P mode perception. The MIDI controller has a knob to control the opposing color pairs in the background and the foreground. The Spotlight Cogcue aims to facilitate P mode perception by directing attention to specific areas through the use of projected white shapes simulating spotlights on different features of the mannequin. This enables users to focus on local details. We conducted a within-subject study in which 12 participants were tasked with drawing the mannequin under 4 conditions, once with each of the 3 Cogcues and once in a control condition without projection. We recorded the drawing process, the drawing object, and all MIDI interactions throughout the study. We report the cognitive load of our system in still life drawing tasks as assessed by the NASA Task Load Index, a drawing analysis by expert raters to evaluate the effects of the Cogcues on drawing performance, and a thematic analysis describing the experience of reconfigurable Cogcues. Users found increased agency in using the grid Cogcue because the grid was a familiar percept. However, for many participants, their ability to remain in P mode was complicated because of its familiarity. We see instances of the grid becoming almost rectilinear despite the curved surface of the mannequin. For the invert Cogcue, intermediate drawers reported greater self-efficacy and agency. Novices experienced the opposite effect. This could be attributed to the Cogcue's simplicity, which allowed experienced drawers to apply their already developed skills, but lacked the proper explicit assistance for novice drawers. The increased construction marks in this condition served as a spatial reasoning strategy to better depict the object's 3D structure. This suggests that to support greater agency and self-efficacy, Cogcues can focus on passive sense-making strategies and provide a stronger sense of perceived assistance as scaffolding for novices. Spotlights were effective in commanding users' visual attention, yet like the familiarity of the squares in the grid, constancy effects continued to undermine the shift into P mode. Users struggled to capture the circular spotlight's distorted form. Therefore, Cogcues should be designed with unfamiliar and low-complexity marks, especially for segmentation and visual selection. Many participants adapted the Cogcues to suit their needs, different from the intended purpose. Some discovered that changing the hues in the invert condition heightened their ability to discern values and depth information. Additionally, while the spotlight and grid selection were designed to track progress and focus attention, all participants leveraged the light casting ability to dramatize shadows. Other perceptual skill training systems are centered around corrective feedback, step-by-step tutorials, or gamification. Although effective, these behavioral approaches ingrain a right and wrong mentality, which can hinder exploration and growth in skill development. Our work promotes a bottom-up approach for achieving P-mode perception through the use of Cogcues. Although our work is focused on achieving more realistic depictions, not all artists desire or use realism. While our work is best suited as a supplement for learning foundational technical skills, future drawing support tools can encourage exploration and development of distinctive art styles. By projecting on the drawing object and not the workspace, we demonstrated a novel use case of the LPSAR system that evades the occlusion problem in the drawing studio. Projected light cues offer great potential in leveraging the ambient environment in creative practices, as they can be mapped to various materials and tools. Similar systems could use Cogcues to give users feedback, support, or greater control over their environment. While we focused on visual cues in drawing applications, we envision additional interactive Cogcues to hack and influence our other sensory systems in other forms of tacit knowledge, such as in wine tasting or perfume sampling. Our findings open up new areas of research in exploring how creative technologies can enable users to become more aware of and have more self-efficacy with their perceptual abilities. In this work, we contribute a novel use case of a projection-based system that overcomes occlusion problems in the drawing studio, 3 scene dynamic and parametric projected light cues to counteract drawing misperceptions, and a formal user study that reports the cognitive load of our system and the effects of the Cogcues. We demonstrated that LPSAR systems can improve novice learners' observational drawing skills by rendering cues for proportion, placement, and shape. This study maps a space for SAR systems to alter perception and improve perception-driven cognitive skill development through perception hacking. At this time, we'd like to thank the anonymous reviewers for their valuable feedback, Professor Yana Payusova for her insights on drawing behaviors in art education, and the peer support from the Hybrid Atelier. We are also grateful to Dr. Rebecca Chamberlain for sharing her wisdom on the perceptual foundations of drawing ability, and to Dr. Jennifer Jacobs for her support and mentorship throughout this project. We also thank the National Science Foundation and our research participants for making this project possible. Thank you for watching, and I hope you have a great day.